We're going to go over a problem in this video that was commonly misunderstood in a previous period. So I have a triangle, has three sides. Two sides are called the legs, and the longest side is called the hypotenuse. I can use the Pythagorean theorem to figure out this length. It doesn't matter which side we call A and which side we call B in terms of the legs. So A is going to be 4 for me, and B is going to be 2 square roots of 7. Now here's where the mistakes was made. I'm going to write down 4 twice, 4 times 4. And if you want to put parentheses around them, you can. And then I'm going to take this quantity, 2 square roots of 7, and I'm going to write it down twice because it's squared. 4 times 4 is 16. 2 times 2 is 4, and the square root of 7 times the square root of 7 is the square root of 49. Now the square root of 49 is actually simplified to 7. So you have a calculator in front of you. Please take 16 plus 28. What is 16 plus 28? Do you end up with 44? Can you please check and tell me if that's correct? 16 plus 28. Is that correct? It is 44? And it is 44. So we have 44. And now in order to isolate this C, I'm going to take the square root of both sides. So C is equivalent to the square root of 44. Now I do need to ask myself, can I simplify 44? Well, how would you know that? Well, you got to go back to those perfect squares. 1, 4, 9, 16, 25, 36, 49. Here's where 44 lands. And so I'm going to grab a calculator and I want to know, do any of these nicely divide into 44? And if so, what's the largest one? So I take 44 and divide it by 36, which is 6 squared. That doesn't work. 44 divided by 25, and I go all the way down. The first one that works is 4. So 44 divided by 4 does simplify this. So I'm going to rewrite this as the square root of 4 times the square root of 11. 4 times 11 is 44. And I know the square root of 4 is 2. This is the simplified expression to the square root of 44. So up here I'm writing 2 square roots of 11. Now once I've been able to identify all three sides of the right triangle, I can now evaluate for a particular angle. Let's go ahead and let's make this angle down here theta. So there are different acronyms that help you remember this. Off to the side, if you've forgotten, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. These two have a relationship. We don't like to say the word opposite because you assume that means the sign changes. They're reciprocal. So whatever the sign is, I'm going to flip it, and that becomes the cosecant. Whatever the cosine is, I'm going to flip it, and it becomes the secant. And the same for tangent. But they keep the same sign. So let's do the sign. You ready? Here's my angle. What side is opposite of this angle? Opposite is 4. What is the hypotenuse? 2 square roots of 11. I'm going to leave it like that right now. Mathematically, it's not wrong. It's just not proper. We'll come back to it later. Cosine. Cosine is adjacent. Adjacent means that it helps make the angle. Helps make the angle, but it can never be the longest side. So if it can't be the hypotenuse, then right here is the adjacent side for this angle. So adjacent is 2 square roots of 7 over the hypotenuse, which is 2 square roots of 11. Tangent is opposite over adjacent. Opposite over adjacent. So 4 over 2 square roots of 7. Okay, now I'm going to start by flipping this. So I'm going to flip it 2 square roots of 11 over 4, 2 square roots of 11 over 2 square roots of 7, 2 square roots of 7 over 4. And last, what takes a little more time is we need to put everything into proper form. What does that mean? It means our final answer cannot have a square root in the denominator. So this does not have a square root in the denominator, but look at 2 and 4. If you're not great with doing that mental math, you can take, and by the way, these are like terms. Right? They both don't have a square root of them. So I can go 2 divided by 4, I could hit math, fraction, enter, enter, and I can see 2 over 4 reduces to 1 over 2. So this can be rewritten as 1 square roots of 11 over 2. I reduce the 2 and the 4. Same thing down here, 2 and 4. So 2 divided by 4, I could rewrite this as 1 square roots of 7 over 2. We're going to come back to the cosine and the secant in a little bit. Let's do sine and tangent now. Sine and tangent. Now before I even worry about reducing things, the big problem we have right now is we cannot leave our final answer with the square root in the denominator. So what we're going to do is we multiply by what I'm trying to get rid of. And I'll tell you even a faster way. If you remember this from before spring break, the quick way of doing this is taking the square root and you throw it up top. I throw it up top. So I just threw it up top, and then I rewrite the denominator like it was, but instead of having a square root around it, it just has the number. So 4 square roots of 11 over 22. Now, I want to show you how this mathematically is not wrong, but this is mathematically correct and in proper form. Please watch. I have 4 divided by 2 square roots of 11. Oops, forgot the 1 there. Of 11. And we can see this is equivalent to approximately 0.603. Okay, let me show you right here. We have 4 square roots of 11 divided by 22. And we can see they're the exact same value, but this is in proper form. When I say go, I'm going to give you 30 seconds, and your goal is to rewrite this mathematically equivalent and also in proper form. 30 seconds, begin. $20 seconds remaining. $10 seconds. You may be wondering, like, where do I start? I'm going to take the square root of 7, I'm going to throw it up top. So I have 4 square roots of 7, and now on the bottom I'm going to rewrite the 7 with no square root. So 4 square roots of 7 over 14. All of this is great, but I see the two that are like terms, this 4 and this 14, they're both even. I know they can be reduced. If you can't do it in your head, you're going to hit 4 divided by 14, hitting math, fraction, enter, enter, and I can see this is going to reduce down to 2 is on top and 7's on the bottom. Okay, turn to people within your group. I want you to look at cosine. Don't do it. Just talk with your partner. What do you think we could do to rewrite the cosine in a proper form? I'm going to give you 10 seconds to talk. Ready? Begin. We are taking this term and we're going to throw it up top. So here we go. 2 square roots of 7, square roots of 11, and on the bottom will be just 2 times 11. Same thing we did previously. Now, how do I know what I can multiply? Well, notice that these are like terms. I know 7 times 11, not only are like terms in this situation, but 7 times 11 is 77. So I have 2 times the square root of 77 over 22. And my last thing will be to reduce the 2 and the 22. And if you can't do it in your mind, 2 divided by 22, math, fraction, enter, enter, and here we go. We have 1 square root of 77 over 11. Okay, here's your next one. You have 30 seconds right now in order to rewrite this in equivalent and proper form. Begin. Okay, if you are lost in what to do, we want to rewrite it so we have no square root on the bottom. So I'm going to throw this up top. 2 square roots of 11. The 7 is going to join up top. And then I'm writing it as 2 times 7 on the bottom. But just like we did previously, I think I'll have a little more room down here. The 11 and the 7 are in like term form here, so I can multiply them. So 2 times the square root of 77 over 14. And if you can't quickly reduce 2 and 14, you're going to take 2 divided by 14. Math, fraction, enter, enter, and I get 1 square root of 77 over 7.